Welcome to Ascending Grades. We are in the marathon in preparation to the Kcse of 2025. For us today, we shall be having a physics paper 2 theory paper. In case you have any inquiry, you can do so through my 24/7 online number 0757 01 9011. This is a paper from Teso Joint Evaluation Test 10 JET. It was done this year, July, and it is one of the papers that are heading towards the prediction, or we can say mobilizing for a good and a better situation when it comes to the Kcse of 2025. Meanwhile, Ascending Grades is thrilled to have you on board for a December holiday tuition program. It is a 5-week session. We shall be having the sciences and the mathematics, and therefore you can always reach me through the number that is appearing on the screen, 0757 01 9011. Therefore, in case you are having a friend who is in Form 3, who is moving to Form 4 come next year, and our Form 2 is moving to Form 3, then you can highly encourage him or her to enroll to our platform. We shall also be having the JS students, grade 7 and 8, and also invite for those who will be joining grade 7 come next year. Welcome. Don't forget to subscribe to our channel. Now we can go straight to the working of this physics paper 2. We have the instructions over there. We're going to start with section A, which comprises of 25 marks. Then we're told the first question: a sheet of glass is that is pendant silvering on one side can enable you see image, but a sheet of a paper like the one you are writing on cannot produce your image. Explain this observation. So in this case, we have to look at the reflective properties. We know that we have two types of reflection, where we have regular and irregular reflection. So we have regular and we have irregular reflection. A surface that is giving regular reflection will produce images, but the one that is irregular will not produce images. So in this case, the silvery painted glass is going to produce an image because it becomes a smooth surface, whereas the sheet of paper will absorb most of the light and therefore will produce irregular reflections. Therefore, a silvered sheet of glass produce regular reflection while a sheet of paper produce diffuse or irregular reflection. Can also say it reabsorbs most of the light. The paper. Set the unit of charge. This one is given by Coulomb. It is denoted by C. A 4 microfarad capacitor is charged to a potential difference of 120 volts. Determine the energy stored in it. Determine the energy stored in it. This is like the work done. And in this case, the energy will be given by this work or energy. Work or energy will be given by half CV squared. And this will be half times capacitance of 4 microfarads. We convert it into farads, so it is 4 times 10 raised to power negative 6. We get farads times a voltage of 120 squared. This one is going to give us 2.88 times 10 raised to power negative 2 joules. Work done or energy through a capacitor is different from when you are told what will be the energy or the work done in a current carrying conductor. So you need to look at the difference. Explain why it is dangerous to light a cigarette near charging car battery. We all know that during the charging of a battery, we have production of hydrogen gas. And remember, hydrogen gas is highly flammable. Therefore, hydrogen gas produced during charging is flammable. It's flammable. Hence, can ignite and cause explosion. Cause explosion. We have our question 4. We're given two graphs A and B. They do represent two electrical materials. You can see one is producing a straight line, and the other one is producing a curved graph. This is a potential difference against current. Let's look at what the question is demanding us. State the law associated with material whose graph is represented by B. So B, we can see, is like we are almost giving a direct proportionality. And therefore, B will be giving us a law called Ohm's law. Ohm's law. And how is it stated? That current flowing through a conductor is directly proportional to the potential difference across its ends. Provided that temperature and other factors are held constant. Give a reason why the material represented by A does not obey the law you have stated above. So we have stated the Ohm's law. So if you look at it, this one, it is not obeying the Ohm's law. So if you look at it, it is not a straight line, no proportionality. Therefore, we can say the potential and the current are not directly proportional. Potential difference and currents are not proportional. What is the significance of the slope obtainable from the graphs? So our graph B is like this. Then we have the current here. So the slope will be given by change in voltage over change in I. And therefore, you know that V over I gives us R, where R is the resistance. Where R is the resistance. Suggest one way of reducing echo in theater halls. Remember, in the theater halls, if these walls are not meant to absorb most of the sounds, then they are going to produce a certain effect called reverberation. Therefore, this question is like asking, how do we reduce the effect of reverberation in theater walls? You can use absorbent materials on walls. Use of sound absorbent materials on the walls. You can also do covering the walls. You can also do covering the walls, but we have been asked only one, so you state only one. Figure 2 shows a permanent magnet suspended by a string. State with reason the behavior of the magnet when it is switched. The switch is closed. So the first thing you need to look at this electromagnet here. You can see we are having our positive terminal here and our negative terminal here, meaning that the current is flowing in this direction. So our current now is moving in this direction. Then you first identify what will be the polarities of X and Y. But the interesting part is X. So using the right hand, you grasp the coil, this one, and make sure that you engulf using your fingers to follow the direction of the current. Then automatically the thumb will point to the North Pole. So in this case, if you place following the instruction that I've given, then our X becomes our North Pole. Automatically, this one becomes our South Pole. So from the law of magnetism, where we have like poles repel and like poles attract. So this is on south, north, and like poles. So we expect these permanent magnets to move towards these electromagnets. Therefore, the explanation you can give is that the magnets is attracted to end X of the electromagnets. So when the switch is closed, now we are explaining why is attraction occurring. When the switch is closed, X acquires a north pole, which is attracted by the south pole of the magnets. So that becomes the explanation. State one factor that varies the strength of the electromagnet XY if the setup remains the same. This question is very tricky because you are told that the setup remains the same, meaning that the number of cells remains the same, the number of coils remain the same, the length of the electromagnet remains the same. But from this diagram, we have something that can be altered. If you look at the diagram well, this is a variable resistor. So what can we do with it so that we can change something? We can only alter the amount of current flowing. Therefore, the factor that can vary the strength of the electromagnet is that the amount of current flow. And why do we say this? It can be varied or adjusted by use of the variable resistor. I've just given out a supportive argument so that you can understand Why do you have to stand for that part? We have our question 7, but before then, we can have our online school, that is Ascending Grades, is thrilled to have you on board for the December holiday program. We shall be having the sciences and the mathematics. You can enroll through the number that is appearing on your screen, 0757019011. Therefore, you can refer to a person, a friend, a colleague, and you will be blessed. Now I can continue. State one property that makes blue light considered as part of the electromagnetic spectrum. The blue light as part of the electromagnetic spectrum. In electromagnetic spectrum, remember all the radiations there, they travel at the same speed, which is of 3.0 times 10 raised to power 8 meters per second. Therefore, I can say it travels at a speed of 3.0 times 10 raised to power 8 meters per second. Electromagnetic spectrum, they have the property that they are part of transverse wave. It is a transverse wave. So these two makes it to be part of the electromagnetic spectrum. We have others, such as it is not affected by electric fields or magnetic fields. And it also travels in straight lines. Convex mirrors are used as driving mirrors in vehicles. Give 2 reasons as to why convex mirrors are preferred over concave mirrors. They form upright or erect images regardless of the object distance. And we have the second one, they provide a wide field of view. We have our question 9, which reads, X-rays are emitted when a tube operates at 2.0 times 10 raised to power 4 volts and a current of 0.015 amperes is passing through it. Calculate the number of electrons striking the target per second. So in this case, we know that the electrons are the ones responsible for the carriage of current. Therefore, current will be given by, the amount of current will be given by the number of electrons times the electron charge. the number of electrons times electron charge. Therefore, our current here is 0.015 amperes is equals to the number of electrons times electron charge of 1.6 times 10 raised to the power negative 19. So our N, when meant the subject formula, it becomes 0.015 divided by 1.6 times 10 raised to the power negative 19. And this one becomes 9.375 times 10 raised to the power 16 electrons. So this will be the number of electrons responsible for production or carriage of current of 0.015 amperes. Figure 3 shows a circuit with a PN junction and a very low power bulb. State with the reason the observation made when the bulb when the switch is closed. This one is going to light because this one is set to have a forward bias. The light bulbs. So the first thing is you start with the observation. The bulb lights. Then now you give now the reason. The diode is forward biased. So that one goes straight. We have our question 11. State two conditions necessary for total internal reflection to occur. The incident angle. And for those who have been following our channel, you can see that this question is common to most of the papers. Therefore, incident angle must be greater than the critical angle. And number 2, incident ray must be traveling from an optically dense media to a less dense media. So those are the two conditions. Ascending Grades Online School is thrilled to have you on board for the December holiday program. We shall be having a 5-week session. You can enroll through 0757019011. Tell a friend to tell a friend. We have section B. Define the term diffraction as applied in waves. So it is the spreading out of waves after passing through a barrier or an opening. Can look at part B of the same question. The figure shows waveforms before and after passing through an opening. Then you are asked, state what would be observed on the pattern after passing the opening if the first condition is when the gap was made smaller. This one. If this gap was made smaller, then we expect circular waves to be produced. And the other thing is that the distance between the waveforms also increases. So we can say circular waves are produced. The gap between the circular waves increases. In short, if this was lambda 1 and this becomes lambda 2, then we shall say lambda 2 will be greater than lambda 1. The gap was made very large. In this case, we produce straight waves. We produce straight waves. Straight waves will be produced. Will be produced. The ones that look like this. So these will be the wavefronts that will be produced. When a meter rule was placed in a ripple tank, it was noted that the distance between two 12 successive dark lines, that is crest, was 30 centimeters. The frequency of the vibrator was 20 hertz. Then you have to determine the wavelength of the waves in the ripple tank. Wavelength is defined as the distance between two successive crests or troughs. And since here we are given 12 successive crests, and all of them, they are given an average distance of 30 centimeters. Then from this, we can get the wavelength. So our wavelength here will be given by the total distance for 30 crests divided by the number of crests. And this gives this one is going to give us 2.5 centimeters. The periodic time of the waves, we are told that it has a frequency of 20 hertz. So we know that frequency is given by 1 over t. Therefore, t will be given by 1 over f. And this is 1 over 20, giving us 0.05 seconds. If you cannot write a small s for seconds well, then write in words. And now you ask the velocity of the waves over the surface. The velocity. So Roman 3, velocity of the waves. So velocity is given by F lambda, and this will be a frequency of 20 times 2.5. And this is going to give us 0, that is 50 centimeters per second, 50 centimeters per second, or 0.5 meters per second. Now I can proceed this one. We have already done it. Can now proceed. We are having an image formed by a converging lens. This is how it is looking like. You can see we are having our lens from here. We have our F1, we have our F2. We have the object is placed 24 centimeters from the lens, and then it is forming an image that is upside down at that point. Then you are told state the value of the focal length. You can see the distance from the optical center here is 10 centimeters to F1. So this becomes our focal length F. So our F is 10 centimeters. Then you are also told to determine the power of the lens above. Power is given by the inverse of the focal length. And the focal length in this formula must be substituted in SI units. So it will be 1 over this one. It will be converted into meters, which becomes 0.1 meters. Then this becomes 10 diopters. So the units here are called diopters. They are called diopters. We have another figure here. It shows a glass lens in air and these two focal points, F1 and F2. 3 rays of light pass through F1 to the lens. So you can see our first ray, our second ray, our third ray. So our first and third, they have something in common. They are going to be refracted a straight a straight wave. So they are going to emerge straight from this side because we are following some rules that when an array is close and parallel to the principal axis of a convex lens, then it will be converged, will be refracted through F. But now in this case, the incidents are the ones that are from F. So they are going to be refracted out a straight rays like that. Now, the center ray, this one, is passing through the optical center in this manner. So it is going to emerge through and deviated. It is going to emerge through and deviated like that. So this is 1, this is 2, this is 3. Must indicate the direction. Must indicate the direction. We can move to the next part. We have our part C. You look at that diagram over there. You can see we are looking at an object of an apple. Then it is formed behind the retina. It's formed behind the retina. So your acts state the defect represented in the diagram. The first thing is you look at it and see that this object is from a very long distance because the incident rays are parallel. So that is an object that is very far. Then we know that distant objects are not formed at retina. So in this case, this one is going to be short-sightedness because you can see the formation of the distance objects there. So in reality, this one is supposed to be formed, or else this person will be able to see clearly objects that are close to rim or R than the distance objects. So call this effect short-sightedness. Give two causes of this one. Too long focal length. Too focal length. Of the eye lens. And we have too long eyeball. A certain, array of light passes through one surface of glass prism at right angles to the surface as shown. Given that the critical angle of the glass material is 42, complete the ray to show how it travels until it leaves the prism. We have a certain question that we tackled, that is question 11, where we said condition necessary for total internal reflection. And the first one we said that the incident angle must be greater than the critical angle. So now, let's look at this one, whether reflection will occur or it will be refraction. So it is incident at this side at 90. So this one is 45, meaning that this one is 45. So if I draw my normal like this, it is going to give me my incident angle here to be also 45. Then 45 is greater than the critical angle, meaning that a total internal reflection will occur. So this one will be reflected out will be reflected out like this. So we do expect also the reflected angle to be 45. So each one is 45, this becomes 90, this becomes 90. So it emerges out and deviated on that side. Then you are told determine the refractive index of the material. Refractive index is related to the critical angle in this formula. Therefore, this is like saying 1 over sine of 42. And this one is going to give you okay, now it is my good viewing. 1.494. Explain why carbon 14 is radioactive while carbon 12 is not. Remember, radioactivity occurs due to instability of the contents in the nucleus. So now, let's compare carbon 14 and carbon 12. Sorry. So, in carbon 12, the neutron proton ratio is 1:1. Thus, A is stable. While in carbon 14, the neutron proton ratio is greater than 1. Thus, unstable. Sorry, this one I was supposed to write 1, just a single one. But it becomes unstable. So the contents in the nucleus of a material, if the ratio is more than 1, then it means that it is unstable. So there is a likelihood and greater chances of radioactivity to take place inside this nucleus. And proceed to the next parts. A radioactive isotope initially exhibited a count rate of 82 counts per day. After a time of 210 days, the count rate dropped to 19 counts per day. The background count ever registered remained at 10 counts per day. Determine the half-life of the material. Before we solve the question, we need to understand what is the meaning of background background count or background radiation. This is just a recorded form of radiation, even when there is no presence of radioactive material. This may be occurring due to natural phenomenon or, okay, yeah, just natural phenomenon. So no presence of radioactive material around, but the device or the one that is used to give out the counts is giving out some presence of radioactive material even when it is not there. Therefore, we need to look at now the actual rates. So initially it was supposed to be 82 minus 10 so that we can get 72 counts. Then the final day, it was supposed to be 19 minus 10, you get 9 counts per day. So it took, or else what remained was 9 counts. So we can use the method of half-life so that we can determine the number of half-lives that happened. So half-life is when a radioactive material decays to half its original mass. So since now, in this case, we're not using masses, we're using the counts, then the counts must be reducing to their respective halves. So initially we were at 72. Then if we reduce this one by half, we shall be arriving at 36. We reduce 36 to half, then we shall get 18. Remember our target is to get 9. We reduce it again, we get 9 counts. Then now you count the number of half-lives. So we have the first half-life, the second half-life, and this becomes the third half-life. So number of half-lives becomes 3. And when they become 3, how do we get half-life? So half-life, which is denoted by TF, will be given by the total time taken T over number of half-lives, N. So in this case, we shall be having 210 divided by 3. You get 70 days as our half-life, TF. A soft reminder that Ascending Grace Online School is thrilled to have you on board for the December all-day program. We shall be having the sciences and mathematics. JS students are also welcome to the program. As for grade 7, 8, and if we keep moving to the next year, then it will be 7, 8, and 9. So for those who are currently in grade 6, 7, and 8, you are highly welcome to this program, a 5-week program, non-stop. Then now we can continue. We have our part B question, where we are given the cloud chamber. So the figure shows pictures of a diffusion cloud chamber used for detecting radiations from radioactive sources. So it is like this. Then, since we are used to this diagram, can just take a few seconds to have a look at it so that you can move to the questions. Then the first question asks us to explain how the chamber works when a radioactive material is introduced at the source. A radioactive is introduced at the source. So this is the source. Then you are supposed to explain. So the radiation ionize the radiations ionize argon gas along their path. Along their path. Along their path. So what happens? The alcohol vapor condenses on the ions. Condenses on the ions. Making it possible for the making it feasible. We're supposed to erase from here. Forming feasible tracks. So I was supposed to respond to a certain question, but I have seen that it is still within the question. So I shall explain further when we get into the Roman 2. So now let's look at this Roman 1. What is the purpose of the solid carbon 4 oxide? The purpose of this one is to lower the temperature in the cloud chamber. Making it possible for the alcohol vapor to condense. Making it possible for the alcohol vapor to condense. This is the question that I was talking about. State one advantage of cloud chamber of the gigamolar tube as a detector of radioactive radiation. This one is able to give the tracks. This one is able to give the tracks, and from the tracks, you are able to identify what type of radiation. So, say the type of radiation can be identified from cloud chamber. Unlike in GM. So if you have to explain this, then you can say that if in the cloud chamber, we produce straight tracks like this, then this one becomes the alpha radiation. If we produce some irregular, but they are just moving upwards like this, they are just moving upwards, this is beta. But now, if we have these ones which are moving just all over, tracks which are moving like this, suppose this is now the source, then this one becomes the this one becomes the gamma. So that is why we have to credit closed chamber to be of more advantageous than the GM. But D, the figure below shows a reductive source with the charge plates in front of it. If the three radiations are produced, sketch the path of each radiation as it passes between the charge plates. So we are going to start right away. We know that we have one that passes through undeviated, and this is we have this one that goes without deviation, and this is the gamma. Then we have alpha is positively charged, therefore we expect it to be attracted towards the negative plate. So this is the alpha. And then we have the other one, which is negatively charged. This is the beta. If you compare alpha and beta, you'll find that alpha moves a very short distance because it is very heavy. That's why if you compare its deviation with this one, the deviation is so strong because it doesn't move a longer distance, because naturally it is heavy. Give two reasons as to why in a lighting circuit lamps are connected in parallel. They are connected in parallel. So we have the first part, the first question. Remember, if these ones are connected in parallel, if you switch off one bulb, then the rest must also continue lighting. In short, to make the lamps operate independently, to make the lights operate independently. We also have another reason. Reduce the effective resistance. Remember, in a parallel connection, we reduce the effective resistance. We can also have to make them operate at the same potential. Make them operate at the same potential. We can now resume our part B. In a 3-pin plug, the half pin is longer than the other two. Give a reason for this observation. We have 1, it helps in opening the shutter. It helps in opening the shutter. For neutral and live pins. And number 2, it secures a device circuit. Because in case we have something in excess, it will first go through the hard pin. The figure shows a bicycle dynamo. You can see it. We have our hexo here. This is the part that will be made to rotate. We have our magnets. This is just a soft iron core. Then we thought briefly describe how the bulb can be made to light when one writes. So I'll give the writing just slightly below the question and not on the selected parts. So on writing, the bicycle makes the axle to rotate with the cylindrical magnets. Inducing some EMF on the coil. Hence, the bulb lights. So that is how it is meant to light. So this one is already handled here. Set one way of making the bulb light brighter. So increase the speed of rotation of axle. So if you cycle very fast, then you are going to increase the speed of the rotation of this. A transformer is used to provide a power to a 12V lamp from an AC remains supply of 240 volts. Determine the number of turns A transformer is used to provide power to a 12V volts lamp from an AC main supply of 240 volts. Determine the number of turns in the secondary coil if the primary coil has 1000. If it has 1000 primary turns. Here we go. So we can first analyze the question. So the voltage at the primary is 240. The voltage at the secondary is 12 volts. The number of turns in the primary is 1000. Our question is demanding us the number of turns in the second. Therefore, we know that from the formula NP over NS is equals to VP over VS. Therefore, 1000 over NS is equals to 240 divided by 12. So my NS becomes 1000 times 12 divided by 240. And this is giving me 60 tons. 60 tons. We have our last question, question 16. Draw the symbol of a photoemissive cell. So this is how it looks like. So this is the cathode. This is the anode. State three factors that determine the emissions of electrons. The emissions of electrons on metal surfaces. This is like asking factors that affect photoelectric effects. We have intensity of radiation, energy of radiation, we have the type of metal. Then we have the last page. Define work function. Is the minimum amount of energy needed to completely dislodge an electron from the surface of a metal. From the surface of a metal. Write an expression for Einstein's equation. Energy of a photoelectron is given by the work function plus the kinetic energy. So Einstein's final equation, maybe I can start from somewhere. Energy of a photon is given by HF. Hello? E. E. HF. And therefore, this HF will be given by the work function plus the kinetic energy. So HF will be given by the work function, which is HF naught plus kinetic energy is given by half the mass of electron V squared. So this becomes the Einstein's equation. Then you ask, what is thermionic emission? What is thermionic emission? Is the process in which electrons are emitted from a metal surface. When heated to high temperature, or when, okay, let's use when heated. When heated to high temperature. Thank you so much for tuning in. Can get us through our online all-day program come December, starting from 11th November to 12th December, a 5-week program. Thank you, and may God bless you.